So first of all, good morning to our audiences from Latin America and the United States. Good afternoon to our attendees from Europe and Africa, and a good evening to our participants from Asia. I want to warmly welcome you all to this webinar focusing on bottom-up greenhouse gas inventories in the transport sector. Transport-related emissions are on the rise worldwide, and in particular in developing countries and emerging economies. So measures to mitigate climate change in this sector are becoming more and more important. So this is why the quote of the Scottish physicist Lord Kelvin might be also true with regard to emission measuring and climate-related policy development, including NDCs. To provide transparent information on national greenhouse gas emissions is a vital part of the Paris Agreement. Developing country parties already report about their emissions and mitigation actions in national communications and biannual update reports. And national greenhouse gas emission inventories are a key part of such reports. So today we will focus on bottom-up inventory models because these models can enable countries to reduce uncertainties in emission estimation and therefore improve the information for decision makers. But they also require an extensive amount of data collection and handling and a relatively high capacity of experts involved. So I hope in the next 90 minutes we will illustrate for you the basic requirements and challenges of such approaches. So before I stick to the agenda, we also want to get you a little bit better. I already know that we have people from various different countries and institutions listening, but I don't know how you are related to the topic. So that is why we wanted to ask you the following questions. So we are waiting a little bit until everyone had that chance to answer. Yeah, the first question is if the people have practical experiences in greenhouse gas inventories in the transport sector. So that is interesting. The majority is actually working in practice and has practical experience. So I think that will be very enlightful for our discussion in the end. So the second question is, how would you rate your knowledge then on GHG emission inventories? Okay, so I see a good chance that after this session everyone can still improve its knowledge a little bit. A lot of audiences right now have only like half of them have only basic or little prior information, so that I think. Yeah, so now I go on. I just want to shortly present ourselves and give a little background on the webinar. So it is organized by two projects implemented by the Deutsche Gesellschaft für internationale Zusammenarbeit, GIZ, the German Development Cooperation Agency, on behalf of the German Ministry of the Environment, Nature Conservation, Building and Nuclear Safety under the International Climate Initiative. The GIZ is a fully publicly owned, no-benefit enterprise that provides service worldwide in the field of international cooperation for sustainable development and is also the implementing agency for bilateral projects of the German federal government. We operate in more than 130 countries with a total business volume of more than 2 billion euro and employ more than 17,000 people, and most of them are national staff. In the transport sector, we work in various fields besides transport and climate change. So, for example, sustainable urban mobility, road safety, and other topics, as you can see. So, as I said before, the webinar is organized by two GIZ projects. As you are only hearing my voice, I shortly want to present myself. My name is Elena Scherer, and I'm representing the TREX project today at the Advancing Transport Climate Strategies in Rapidly Motorizing Countries project, and we are supporting partners in systematically measuring and reducing emissions in the transport sector, and therefore facilitating sectoral contribution towards achieving their nationally determined contributions. So my other colleague, Verena Schaus, will represent the Information Matters project. She's the coordinator for 3 partner countries, Vietnam, the Philippines, and Ghana. And this project aims to strengthen in-country capacities for enhanced reporting to the UNFCCC. Here you can see, waiting for the slide to come, yeah, here you can see in what countries we are working. And both of the projects are working in Vietnam, and we are very lucky that later on we also have a representative, Miss Yen from Vietnam, who will give us more insights how they are working on the establishment of bottom-up emission inventories in the transport sector. So now I already come to the agenda. We are in the middle of the welcome and introduction, and I already have introduced myself. So let's go on with an overview of what you can expect today. So we will start with a presentation that gives you an overview and an introduction on how to develop GHG inventories in the transport sector, and Christoph Heid will also share some experiences from Germany with you, and then we get to know a different point of view here from Vietnam, who will tell us Ms. Yen will tell us how this will work in practice and what challenges Vietnam is facing. And to conclude, we'll have a short input of Marion Viehweg, a very special short input on how these bottom-up calculated inventories can also be used to evaluate specific measures. So now you will just see our speakers, as we are not sharing a video. That would be maybe a little bit too complicated with speakers from different parts of the world at the same time. So Christoph Heid is working for the IFO Institute since 2011 as a researcher. The IFO Institute is the Institute for Energy and Environmental Research, a non-profit research institute founded in 1978. And the IFO carries out the transport emission model, TREMOT, that calculates the emissions of the motorized transport in Germany on behalf of the German Federal Environmental Agency already since 1993. Later on, Wolfram Knör will also join the Q&A session so he is also available to answer your questions. Ms. Yen, who will talk about Vietnam, is the Deputy Director General of the Transport Development and Strategy Institute, TDSI, which is an administrative agency of the Vietnamese Ministry of Transport. Furthermore, she's a member of a GHG inventory working group that was set up for the inventory work here in Vietnam by the Vice Minister of the Ministry of Transport. And she's also leading 2 sub-sectoral working groups for the inventory, which are inland waterway and road transport. So the last input will be delivered by Marion Vivek. She works as a senior consultant for energy and climate strategies in Berlin with her own consultancy, Current Future. And she's a specialist in transparency, policy analysis, mitigation, and the link to sustainable development. So I don't know how familiar everyone is with the technique here of the GoToWebinar meeting. So I want to shortly explain the control panel to you, the most important functions. So with the little orange button here marked with number 1, you can hide the control panel or enlarge it. And with the second below with the little microphone, you can mute yourself. I hope you are all unmuted already. If not, please switch off your microphones to avoid any interference here with the sound of the speakers. And please also switch off your camera. So with the third button, you can see the presentations in full screen format. And now the most important function for today, if you have any questions or technical problems, you can use the question window. So if you raise a question here, we can raise it up later in the discussion, and our experts can reply to it because we have served plenty of time for the Q&A session. And if we do not manage to discuss all the questions, we will send you the answers in written form afterwards. So this is from my side. I'm very happy to hand over to Christoph Heid from the IFA Institute to continue with the next presentation.
Okay, hello to everyone, and thank you very much for your introduction, Elena. I will open my presentation now. Okay, so the topic of the first session today is how to develop a bottom-up greenhouse gas inventory in the transport sector. Like Elena already mentioned, our company EFOI has some experience and worked on this field for almost 30 years, especially Wolfram has a lot of experience for the model in Germany, but we also had some insights in international activities recently in Vietnam, which Ms. Yen will report later, or in China. So I hope in the next 20 minutes I can give you some helpful insight on this topic. The contents of my presentation will first be an introduction in bottom-up approach for greenhouse gas inventories, also a comparison of bottom-up approach versus the top-down approach. The second part will be like more explanation of the methodology and the input data. What data will you need to develop a bottom-up inventory? How can you get it? And the third point is an example of some data collection in Germany, how we do it here and which institutes are involved. And last but not least, I will present some data sources and references which might be helpful for future work. So first point, introduction. What you can see here on the first slide are the UNFCCC categories for the greenhouse gas inventory, and their transport, which is here in the middle, has the code 1A.3. It is part of the energy sector in the greenhouse gas inventory, and further a part of fuel combustion activities. So this like the general location of transport sector in the inventory. More to the right, you can see that there are different subsectors in transport. First, like the transport modes, civil aviation, road, railways, navigation, and other transportation, which is basically off-road equipment. And then we have like further levels of this aggregation, which can be used in a greenhouse gas inventory, like for the road sector, passenger cars, light-duty vehicles, heavy-duty vehicles, and buses, and so on. And even further disaggregation in technologies. So looking again at the topic of today, where is a bottom-up approach helpful? I think in general you can say the more disaggregated a greenhouse gas inventory needs to be, the more helpful it is to use a bottom-up approach. For example, if we want to separate different engine technologies like cars with a three-way catalyst or without catalyst, also vehicle categories like cars, trucks, buses, and so on, it is very helpful to use bottom-up data because top-down means that you have only a total number of fuel consumption within a country, and this is a solid base to know the total number of fuel in combustion activities, maybe also in different transport sectors, but it is pretty hard to separate subcategories and also technologies with a top-down approach. So this is a general overview of the two approaches. What can they do? What is the strength of each approach? Here I have some overview of the approach again. So the top-down approach has the main benefit that it is needed for consistency of greenhouse gas inventory. That means top-down, which bases on national energy balance or fuel sales statistics. It helps to avoid double counting. If different countries use the same approach, you can be sure that there is no double counting, that like one country reports fuel consumption which is from another country or the other way around. Also, there is no double counting with other sectors than transport. For example, if fuel is used also in stationary combustion or in industry processes. This kind of separation is already part of the national energy balance, so it's also part of the inventory guidelines that all total numbers of a greenhouse gas inventory must comply to this energy balance. So besides the benefit, there's also some challenge with the top-down approach. Some things a national energy balance cannot achieve. A main problem is that the allocation of fuels is not very easy. For example, if we know the total amount of diesel consumption within a country, we most of the time do not know in which modes diesel is used. For example, very common is that diesel is used in road, but also in railways, in ships, and in off-road. So it's very hard to really tell which sector is emitting greenhouse gas emissions by top-down data. A bit similar problem occurs for kerosene and for HFO, which means heavy fuel oil. The allocation to a transport mode is not so difficult here because kerosene is mainly used for aviation and HFO mainly for the maritime sector. But we usually do not know the split in domestic and international transport here just by top-down data. And this is a very important point for the greenhouse gas inventory because it should only include domestic emissions, not international emissions. So to compare this with the bottom-up approach, here the main benefit is the level of detail. All things we do not know in the top-down approach, we can usually identify in bottom-up approach because fuel consumption and emissions can be disintegrated until the level of subcategories, technologies. So this makes it very detailed and also possible to tell which category, which type of vehicle contributes more or less to the greenhouse gas emissions. And also this is a good basis not only for an inventory but also for policy planning and for scenarios how to mitigate greenhouse gas emissions in the transport sector. On the other hand, a main challenge, like Elena already mentioned in the beginning, is that you need a lot of data, capacity, and also resources to maintain and develop a bottom-up approach. There's first the question of input data, then choosing an adequate methodology because there are different approaches, and also understand data quality and uncertainties. And I want to go a bit more into detail about these last points in the next slides. So about methodology and input data. First, you can see here an overview for the top-down approach. The basic parameters is total fuel consumption, which we usually get from the national energy balance, and specific emission factors. And in case of the top-down approach, it is possible to use default values from the IPCC guidelines, which refer to the Tier 1 approach. And multiplying these two factors, you can calculate the total greenhouse gas emissions. So for a bottom-up approach, the input data and the calculation looks a bit different. I started here with a bottom-up approach based on vehicle stock and vehicle kilometers traveled, or in short, VKT. There's first the number for total vehicle kilometers traveled. This is a very important information if you want to develop a bottom-up approach, for example, for road transport. The number for total VKT, it can be obtained, for example, from surveys, from counts on roads of vehicles, or it can also be done by a bottom-up calculation. And this is shown to the right. So calculation of total VKT can be done by multiplying the number of vehicles, this is vehicle stock, and average VKT per vehicle and per year. Vehicle stock is usually available, especially for road vehicles, from registration data, because most of the vehicles, like cars, trucks, or buses, they need a registration. So there is the data about the number, and often there's also more information, like the type of fuel which is used, size of the vehicle, type of the vehicle, age. So a lot of information there. If you do not have this registration data, for example, there are some categories of other vehicles like off-road engines, equipment, sometimes motorbikes. There is maybe other data sources which can be used, like sales data from the industry, or also insurance data if vehicles do not need to be registered, but if there is an insurance necessary. For VKT, different to total VKT, average VKT is also quite good to get from surveys, for example, interviews of car owners or of private persons, companies, or also collection of tachometer data. For example, this kind of data can be collected in inspection and maintenance services, and then collected and used to get data for the average VKT of each vehicle type, for example, passenger cars, trucks, and so on. If you do not have this kind of data for a national inventory, there's also different literature sources which have default data for average VKT. So this is another option to make a bottom-up calculation. After calculating total VKT, the next step is to calculate total fuel consumption. So The next parameter which is needed here is specific fuel consumption. For example, liters of fuel per 100 kilometer, which is a common dimension for this parameter. And this data is quite often very difficult to get. You can also do surveys, for example, interviews from car owners or from companies, or testing in a laboratory to get data on average specific fuel consumption. Usually, getting this data also needs a lot of resources, especially measurements are quite expensive. So for alternatives with lower resources, you can also use default values here. There are a number of international literature, I will list some at the end, which give default values for average fuel consumption. So, and the last step, similar to the top-down approach, when we have calculated total fuel consumption bottom-up, is to multiply it with specific emission factors. For example, kilogram of CO2 per kilogram diesel or gasoline. And then we can have as a product, again, total greenhouse gas emissions. So the advantage compared to the top-down approach is if we know not only total fuel consumption, but like the disintegration of fuel consumption by vehicle type and also technology, it is possible to use country-specific emission factors. Like there might be a different emission factor for vehicles using three-way catalysts or vehicles not using such catalysts. So it is possible to apply more specific emission factors. So I think this picture is already quite complicated, but I will add more points. So there are a lot of options to control the input data you have used for the bottom-up calculation, and I listed it here. So a very common way of validation is cross-checking. For example, cross-checking total fuel consumption, which was calculated bottom-up with the top-down data from the energy balance. If there is a big difference between those two numbers, then you might have a look at more in detail. Are some of the parameters not realistic, or is there a different level so the data cannot be compared? But in any way, it helps very much to have a better idea if the data is valid or not. Another option for cross-checking is for total activity. In this case, it's vehicle kilometers traveled. If you have numbers for the total vehicle kilometers traveled, for example, from surveys or for counts, you can compare this with the bottom-up calculation using vehicle stock and average VKT. Quite often this is a point which is very uncertain because it's very hard to find out how much of the vehicles are really in use and to get like a realistic average mileage. So it's very good if we have both types of data, total VKT from measurement and also calculated VKT from stock and average. Last but not least, there are further possibilities for validation, which is comparison of default values and the country-specific data, for example, for average VKT. If there is a difference, for example, in Germany, a passenger car will drive 10,000 kilometers per year. If you have a value which is much lower or higher, you probably need to explain it, if it is realistic or not. Other comparison can be done for specific fuel consumption or for the specific emission factors. Okay, so this is an overview about the methodology and the data requirement. Now I want to give some example for data collection in Germany. First, data for vehicle population. In Germany, this data is collected by the KVA, which is a type approval authority related to the Ministry of Transport. And They have like a website where a lot of the data on vehicle population is also published. And for example, for the German inventory, we use the number of vehicles in total, so stock and new registration. And the key information here is beside the total number, the vehicle type, vehicle size, like weight, capacity, engine power, the fuel type, year of registration, and also an available parameter is the fuel consumption related to the information from the manufacturers, so type approval cycle. And this data we can get annually from the KBA, which is a very good database. A second parameter for vehicles kilometer traveled. We also have different data sources in Germany. The most important institution here is the BAST, the Federal Highway Research Institute, which is also allocated to the Ministry of Transport. And they make surveys for total VKT by the type of vehicle and also the type of roads, like highway, rural roads and urban roads. And they do automatic traffic counting every year on the major roads, some manual traffic counting for all roads every 5 years, and more detailed studying surveys combining counting data but also inspection data and interviews around every 10 years. So this is basically the data we use for total VKT in our inventory model. And then there's also some data for average VKT, which has much more information based on the vehicle type, vehicle size, fuel and age. So this also adds up to make the calculation more in detail. For example, diesel cars in Germany have a much higher average VKT than gasoline cars, or big cars have a higher mileage than small cars. And this can be shown by using the data from the mileage survey. Last point for the inventory, specific fuel consumption and emission factors. I don't want to go too much into detail here, but for the German inventory, our data bases on the Handbook for Emission Factors of Road Transport, in short the HBEFA. It is a model which is used in different European countries, and it has not only fuel consumption but also air pollutant emission factors in a very high level of detail. So it is possible not only to use it for national inventory but also for micro traffic situation, like input analysis of road section emissions or urban emissions. So it's the same data source used for different purposes in Germany. Another important source is the European Research Group on Mobile Emission Sources, or ERMES. They basically coordinate activities on vehicle testing and also the allocation of governmental resources on a European level. This is very important because, like I mentioned before, measuring and testing of fuel consumption and emissions is quite expensive. So there's the cooperation here of different EU countries to coordinate their budget to have the best output of their resources. Last, for this example of Germany, I want to show some results. This is not very up to date, it's from 2010, but I think it's still good to demonstrate like what the comparison of a bottom-up versus a top-down calculation can look like. For petrol, we can see here that the bottom-up data, it's a bit higher than the number of fuel sales, and petrol consumption is mainly in road, and a very small part is in other sectors. So there is some difference which cannot be really explained. There might be some difference from gray imports, cars buying their fuel in other countries, but then traveling in Germany. So there is a difference between VKT in the country and fuel sold within the country, which can be explained. For diesel consumption, as mentioned in the beginning, it's a bit more difficult because we have more sectors here. For example, road has the highest share, but then there is also a small share of rail, ship, and also other sectors like construction equipment or agricultural. And there's also the result of the bottom-up calculation is a bit higher than the result of the top-down analysis. But overall, this kind of uncertainty, I think it's quite common and it's still explainable. Then I want just to give a short outlook of other bottom-up approaches, especially for non-road transport modes, which can be applied. Something I call here like a simplified bottom-up approach is you could also calculate emissions or fuel consumption by multiplying transport performance and an average specific emission factors. And transport performance, this is basically the ton kilometers or passenger kilometers. And data on this is often available for freight and passenger transport in national statistics. So it can be used for road, rail, aviation, or waterways. And in Germany, for example, we used this approach many years for the inland waterways before we had better data to use the detailed bottom-up approach. So pro of this kind of simplified bottom-up, it's really easy to manage, and there's a bit more uncertainty because you already have a total number for transport activity, like the total transport performance, and also it enables simple projections. For example, if the transport activity increases, then you can also project if the total fuel consumption increases, even if you don't have like the number for total fuel consumption. The contra or the problem with this approach, it's not very accurate. So you cannot use very detailed emission factors. It's not suitable to make policy evaluation or scenarios. And also changes in the vehicle fleet cannot really be projected. Another approach is the so-called population method. Like the name tells, it's based on the population, similar as I have shown for road. But instead of VKT, we can use engine power here, use, which is usually the operating hours within a year average, and an emission factor. And this kind of approach is often used for off-road equipment, where BKT is not a suitable parameter, but rather operating hours. Also, it can be used for ships and trains. And the data availability, it really depends very much on the sector. For example, for ships and trains, we often also have the stock and engine power from registration data. So data availability here is quite good, while operating hours and specific fuel consumption is data you often need to request from literature or industry. So here again, pro of this approach is it's very detailed. It can be used for scenarios and projection, and it is also suitable to calculate not only greenhouse gas emissions but other pollutants like air pollutants. Contra is the data requirement is very high, and also the uncertainties. Yeah, finally, like I mentioned at the beginning, I have here a list of some helpful data from international sources and references, which might be useful if you want to develop a greenhouse gas inventory for transport. First, there are the IPCC guidelines, the 1996 guidelines. It is obligatory for non-Annex 1 countries, which are most of the developing countries, and the guidelines 2006, it's obligatory for the Annex 1 countries, such as, for example, Germany. And the guidelines, they contain the most information about the methodology for reporting, also the default emission factors and conversion factors like heating value of different fuels. So this is a very important source. Then we have the EMAP-EEA guidebook. This is a European data base. It is public, and it has a lot of information also on methodology, default emission factors for air pollutants, greenhouse gas emissions, and fuel consumption. So I think it is very helpful, and it is also a public source. Other important sources is the EAA energy balance, in case you don't have a national energy balance for the total fuel sales. EAA has such a data set which can be downloaded on their website. The World Bank has some information on the heat bus population, transport performance for different countries, and some other sources which were also co-developed by IFAO Institute is Eco-Transit and Eco-Passenger, some tools for calculating greenhouse gas emissions of different transport modes. And there are some reports where you can find, for example, numbers for our average fuel consumption for different transport modes like trucks, ships, in different dimensions like grams per ton, kilometers, in case you want to use a simplified bottom-up approach. Yeah, thank you very much for your attention. I hope some of the inputs here were helpful for you, and then I will hand over to Elena again.
Thank you very much, Christoph, for this broad, fast input. I think the complexity of bottom-up inventories has become very clear, but also that it's worth to make this work happen. I want to now hand over to Ms. Yen from the Transport Development and Strategy Institute, TDSI, in Vietnam.
Good evening, everybody. Thanks, Elena, for giving me a chance to share with you some of the experience in setting up the national transport emission inventories in Vietnam. So, here are the main agenda that I'd like to share with you. First of all, I'd like to go through the background of the country, what we have been here, and how we work together with the international organization, especially GIS, in the task of GHG inventory. How we come up with the inventory tool, and some of the main challenges and barriers that we encounter during the course, and finally what we will be doing in the near future. You know that transport in Vietnam account for more than 20% of the total energy-based emission. So in Paris agreements, the government just commits to reduce the emission by 8% by the year 2030, compared to the business as usual scenario using the domestic resources, and with international support, we will try to reduce the emission by 25%. As you all know, and maybe it's also similar to many other countries, that the transport sector is highlighted as a focus area in Vietnam in the intended national determined contribution. So in Vietnam, Ministry of Natural Resources and Environment is responsible for the coordinations with other ministries of sector on the matter related to GHG inventory. And in transport sector, Ministry of Transport is responsible for implementations of the sectoral inventories. Here in this graph, you can see that the task is actually initiated by the Prime Minister, and we got a decrease to assign the Ministries of Natural Resources and Environment to be the coordinator, to be the focal points of the GHG inventory in the country. So in order to implement this, the Ministry of Natural Resources and Environment will coordinate other ministry, line ministry, including Ministry of Transport. So within Ministry of Transport, the minister just assign an Prime Minister to be responsible for the task, and Department of Environment on behalf of the minister will set up a task force, a working group to be responsible for this, because transport is actually a very complex sector. We compose of 5 subsectors, including aviation, road, railway, maritimes, and inland waterways. Within the Ministry of Transport, a working group is established, and we work with sorry, I just got some problems moving the slide ahead. Okay, so thanks to the support from GIS, we had chance to participate in chance projects, and with the technical support from IFO, then now we work together since late last year to develop the model and come up with the very initial result of the GHG inventory at the moment. So here you see, this is the tools that we have been working together and developed so far. As you heard from the Christoph presentation, then we all know that there are 2 basic methodologies, top-down and bottom-up, and each of that has its own advantage and disadvantage, good thing and also differences in implemented. So based on the characteristics of each of the subsector and data, especially data availability and the reliabilities of the data that we have in Vietnam at the moment, we decided that for aviation, we're gonna, and also the railway, we will use a top-down approach, which based on the total fuel consumption for the sector. For the road and inland waterways, which are the 2 most difficult subsector, because we got, say, like millions of individual or private car or motorcycle, and also residential shift. So we decided to use the bottom up for those. I mean, it's necessary that we have to use the bottom up methodologies for those subsector. the reason why, first of all, why we can identify pretty well the fuel consumption for aviation and railway that used for aviation and railways sector. For the road, we may have also some the use of the assumption could be for farming, fishery, etc. So it's hard to for the top-down approach to identify which is for road and which is for other sector. Similarly, for maritime and inland waterway, we also have problem of separate or identify clearly if we use the top-down approach, we cannot identify very clearly which is used for maritime, which is used for inland waterway. So we had to use the bottom-up approach. So after we just got the GHG's inventory for each of subsector, then we try to balance it, validate all of these number with the top-down methodologies based on the energy balance of the whole countries, and then so we can come up, consolidate all of the inventory in a merge tool. Here is an example of the model of the tools for the road, that you can see that we just divide into 100 type of categories of the passenger car, of the freight, of the trucks, by size, by fuel types, by emission standard, etc. Then we also need to collect the data on the performance, which is the average loading factors, the average length of that vehicle run per year, average speed, etc. So before we can calculate the GHGs. And here is an example of the output table for the road inventory model. That will come up with the total fuel consumptions based on the emission factors in the IFCCC 2006. So beyond that, so we can calculate the different type of the emission CO2, CH4, and N2Os, etc. All of the subsector will be merged all together in consolidated tools like this that you can see on the screen. Primarily result. This is a very, we just started the assignments half a year, and within very short times, with the effort from hard work from the working group, then we got the primary initial results of this. This is for reference only. We're now improving the qualities of the input data, also the model, so that we may have a better result. But if you look at this, then you can see the levels of the fuel consumptions and also the emissions by subsector. Road for motorbikes, for freight, for buses, for car, railway, navigations, aviation. Here is the a graph to show you the relation between the transport performance by 10 kilometers of the freight, and then the fuel consumption, and then so you can see the from the very initial analysis, you can see the average fuel efficiency by subsector. Similarly, this is the primary result for the freight traffic. So to come up with all those is a very primary result at the moment. So we have learned quite a lot during the course. Challenges, many challenges, but main challenges that we should mention here. So first of all, data provisions is partly not formalized. We had to rely on a number of unofficial data. The database in Vietnam is not quite good at the moment. Why the reported data is not all the times in good quality, but it's not very frequently reported. Some of data are available, but it's located in different institutions. So it takes quite a lot of times to learn about what is available, what is not, what data is available where, and how to get them. And I mean, we also share this with many of our colleagues where that even the data is spreading somewhere, available somewhere, but that is not all the time that we can get the data, especially from the private sector, that they're not all the time willing to provide data for us to the data for bottom-up approach, we all learned that it will require a huge amount of the data, but we really got a very limited resources to collect the data, not to say about the inventories work. So because of the data that we also identify that given what we have so far, we have a different uncertainty level amongst the sector. Why we find that in the aviation and railways, data are more reliable. So the reason is now more reliable. Less uncertainty in this subsector. Maritimes, because for maritimes we encounter different methods of, some vessel may buy the fuel from overseas while it emitted run in domestically and emitted domestically, and then we have to count here. Then there's always the gap between the bottom up and the top down. So we need to have a further study in order to explain about the differences. So we think that for the maritimes, there's medium levels of uncertainty. As I mentioned before, that road and inland waterway are the highest uncertain sectors that we had to deal with. So for road, because of the high numbers of the motorcycle, we have now say like 52 million motorcycle registered, but no one know how many of the motorcycle actually in use. This causes really high uncertainties in the result. We also lack of the performance data. So we need to, and then so we don't have information about driving behavior for the road and road ties, which is needed for the tier 2 emission factor. For the inland waterways, similarly to road, then just roads safe above 50 tons register, and then while we have millions of residential ship, especially running in the 2 delta, the Mekong Delta and the Red River Delta, such are not counted yet. So these are main challenges. So what we're gonna do for the better inventories later this year, then on the one hand, we think that we should produce, we're now working on the procedure for tool maintenance by subsector and the consolidated tool as well. We will further evaluate and try to minimize the uncertainty by, overcoming the shortage and the challenges that I mentioned. We're now working on the 2015 inventory. We will also spend effort on the 2013 and also 2014. So that's we will be having more, reliable inventories for the analysis later on. So this is what I like to share with you today on based on the work that we'll work with the GIS within the TRACS projects. Thank you very much for your listening.
Thank you very much. Thank you very much, Ms. Yen, for this insight from Vietnam. It was very interesting, and I think also very interesting for other participants that might suffer similar challenges in their countries. So I also encourage you to share your experiences in the question window. Yeah, and now it's time for last input from Marion Fivik on the MRV of measures and how bottom-up inventories can be used for them.
Yes. Yes, thanks a lot, Elena, and welcome everybody. And I'll try and be short, as this is only an add-up, and I don't want to take up your time for the questions and answers. You've heard a lot about the inventories and the usefulness of bottom-up inventories, but also the challenges. And looking at those challenges, I thought we would like to look into the usefulness of the data that is generated, making that effort also for other purposes, and particularly for the MRV of transport measures. So I'll just give you a very quick overview. Today we also have a brief technical paper that will be distributed with the materials webinar. So don't worry if I'm going through this a bit fast. You'll have the opportunity to ask questions later and also read a lot more detail in the paper. So I'll first clarify a few issues on terminology, discuss some challenges around boundary setting and differences for, between inventories and the MRV of measures. Then quickly recap the calculation approach for MRV of mitigation measures, and have actually only one example. There's more in the background paper on how you can use inventory data for the MRV of measures, and then briefly discuss what the synergies and limitations are. So on terminology, it is very important to be clear what you're talking about, because there's slight differences between the use of some terms in the inventory guidelines and generally in inventory preparation versus the MRV of measures. You've already seen from Christoph's presentation the basic calculation equation for emissions is activity multiplied by emission factors for the inventory, and in the case of the inventory, activity can mean two different things, either the fuel that's used, which is the tier 1, or the distance traveled, which would be tier 3. In the MRV of actions, we actually only refer to activity in relation to the distance traveled, and particularly either to the vehicle kilometers or the performance, as mentioned by Christoph, passenger kilometers or ton kilometers. So when talking about activity data, it's always important to be clear what you're talking about, because there's different uses. Same goes with top-down and bottom-up. In terms of the inventory, the top-down approach is more defined by the lack of level of detail, by using only overall fuel sales, and the more level of detail you add, the more bottom-up the approach becomes. So, for example, in the 1996 inventory guidelines, the tier 2 is labeled as a bottom-up approach, even though it's still based on fuel consumption. In the MRV of measures, we're only referring to bottom-up as methods that are based on the distance traveled, so on vehicle kilometers or passenger kilometers or tonners. So that's always important to keep in mind when we're using these terms, that they may mean different things, and we need to be clear what we're talking about. So then, coming to some of the challenges in using inventory data for the MRV of measures, the obvious one is the geographic scope. Inventories are at the national level, but measures that we may want to track may or may not be at the national level. Some are, but a lot of them are not. They're at a regional level, in certain cities, or even more narrow, only certain corridors or ride shapes. Additional complexity added is that the different measures that are taken can overlap in their geographic area, and thus there may be interactions and synergies. And there's also a certain overlap or potential overlap with survey areas that are used for inventory data collection, and that's going to get important when we start discussing potential synergies between the two. The other dimension that is very important in this area is the sectoral coverage of the inventory, or of what we're what kind of data we're looking at. In the inventory, there's a clear focus on the fuel combustion in the transport sector, whereas overall, when we're discussing the transport sector, there is obviously a lot more we could potentially look at, and that could be relevant for the MRV of my particular measure, depending on what kind of measure it is. So we have a lot of potential emissions upstream in terms of vehicle production and infrastructure construction. We also have downstream emissions in terms of vehicle scrapping and disposal, and also infrastructure dismantling. In many cases, a lot of these will not be relevant also in terms of size compared to the emissions of the actual activity and operation. But that is not the case for fuel production, and particularly for the use of other fuels that are not covered by the inventory, or at least not covered in the transport section of the inventory, and that is use of electricity and use of biofuels. So that having said all of that, that does not mean we can't use the inventory for the MRV of measures. It just means we need to be aware of these limitations and need to find ways to deal with them. So to go on, we're looking at the basic calculation logic for the MRV of measures, in this case for passenger transport. It's very similar for freight, but to keep it simple, we're looking at passenger transport here. And I think Christoph already very nicely laid out sort of the general calculation logic, and we start with the amount of trips that people usually take, and take that how long these trips are usually, and what kind of mode people travel in, and that gives you the passenger kilometers. Combined with the sort of average occupancy, and then also differentiating that by the vehicle type and emission control technologies used, age, etc., you get to the vehicle kilometers. And then obviously the fuel efficiency and the greenhouse gas emissions per unit of fuel will then provide you with the greenhouse gas emissions. So that's a different way of presenting the same calculation logic. And if we apply that to an example, in this case we've chosen a national vehicle fuel efficiency standard, or efficiency standard which could either target fuels or directly target emissions. We can identify which parameters in this calculation are the ones that are interesting for the MRV of the measure that we really want to look at, because that will determine what kind of information I can maybe draw from an inventory and what kind of information I can't. So in the case of efficiency standards, it's mainly obviously the fuel efficiency and the greenhouse gas emissions per fuel, but it's also the composition of the fleet, and that is mainly the case if it depends a little bit on the design of the standard, but if the most standards are designed in a way that they also promote the shift to, for example, electric propulsion systems or alternative fuels such as biofuels. So this could change the composition of your fleet in terms of what kinds of fuels are used. And then when we look at what kind of information we can actually draw from the inventory, that also it depends on the purpose of the analysis. At what stage are we in our measure? So for ex-ante analysis, for the definition of scenarios and the projection of effects, there's actually quite a lot of information we can draw from the inventory if we have either tier 2 or tier 3 So we have fleet composition data at a relatively disaggregated level. We have fuel efficiency at a relatively disaggregated level. So we can use that data to project scenarios into the future. For ex-post assessments, that is a slightly different story, and we need to we can probably still take the distance traveled from the inventory if we have a tier 3 bottom-up, a real bottom-up inventory that has distance traveled, because that's not affected by the measure as such, but the fuel efficiency data from the actual vehicles sold where the standard applies, that will probably or most likely need to come from other sources than from the inventory. In most cases from sales data that are provided by sellers or directly from manufacturers. So this already shows there is a lot of information we can use from the inventory if we have an inventory that's at a sufficient level of detail. But depending on the purpose of the analysis, there will in most cases also be data that we will need to collect on top of that. So very briefly on what are the limitations of the use of bottom-up inventories for the MRV of measures. Obviously, we've already discussed the geographic scope, so that makes it less usable, particularly for ex-post assessments. So to check if the measure was really as effective as it was meant to be. If we look at the average values that we're using for the generation of the inventory, that's not going to be good enough for an ex-post assessment, but it is certainly good enough for a lot of ex-ante assessments and projections. Also for subnational activities, we can use a lot of the inventory data by downscaling and using different methods of downscaling to the right scope, but also here that's more appropriate for ex-ante analysis than for ex-post assessment. Limitations on the sectoral scope I already discussed. It's for anything that includes electric forms of transport, that includes mass rapid transit, the sectoral scope of the inventory is too narrow, so we need to look at including electricity in the calculations. Of course, also here we can use some of the information in the inventory, but not all of it. And the same is true for biofuels, where we need to include that in the scope. In general, ex-post assessments, it's less useful than for ex-ante. But we also have synergies in the use of bottom-up inventories and MRs. And on the one hand, the data that we may collect, particularly for the MRV of one or more measures, can in many cases be used to supplement available national level data or supplement survey data that is already available for that was actually generated for the purpose of the inventory. And if we coordinate that well between different measures and different geographic regions, we can even use that to produce national bottom-up inventories. I've already mentioned that we can use tier 2 and tier 3 inventories for ex-ante assessments in many cases. And what is really important to maximize the synergies is that data definitions and collection methods are harmonized. So it is, well, at least it makes life a lot less easy for those that are trying to then use the data and maybe put them together to generate a national level inventory. It also helps, obviously, if frequency and timing is aligned, so that the data is actually available at the time when inventories are collated, or when reports due for individual measures are being created. It's also essential that data formats and calculation methods used are consistent, so that I can actually take data and results that have been calculated by, for example, a measure, and use that in my inventory calculations. And I think institutional cooperation was already mentioned in the previous presentation. That is always a challenge, to actually be able to get access to the data. Just that it's there is not enough. You also need to actually get it in the appropriate format, so it doesn't really help to have to type it up from a PDF file if you can actually get the original Excel sheet. That just makes life a lot more easy for those that are then using the data. And that also obviously applies to private sector, which was also mentioned, where this data is only available in the private sector. You need either a legal basis for reporting, or necessary memorandums of understanding, or cooperation agreements that give you access to that data. So that was it, very, very briefly from my side, and I'm happy to take any questions. And as I said, the paper is going to be sent out to you, so thank you.
Yeah, thank you, Marion. We have now some room for discussions. I am very sorry that it's not as much as time as I expected it to be, and I have to apologize for that. But still, we will collect all the questions and then later on provide you an answer in a written form. And I very have to apologize for that. So Verena was collecting the questions during the session, and I will now give over to her so that she can, introduce the questions to the colleagues. And later on, we will also share different information material, like the background paper that Marion has already mentioned. So thank you, Verena, for taking over.
Yeah, thank you very much, Elena, for the introduction. Also, a warm welcome from my side. My name is Verena Schaus. I'm working for the Information Matters project, and it is my pleasure to guide you through the Q&A session today. So before we start, I would like to give a big thank you to all the participants. We received quite a huge number of questions, and unfortunately, like mentioned before, due to a limited time we have, I can only read out a small number of those questions. But as Elena mentioned, the experts will try their best to answer those questions and send it to you via email afterwards. So to start with, we received quite a lot of questions for Christoph about the top-down and bottom-up approach. And the first question will be a summary of 3 questions, actually, which I think are really easy to answer. So, Christoph, what is the difference between bottom-up and top-down approach results, and what results can be used? Then the second, in a developing country context, based on the extensive data requirements, would you recommend a top-down approach during GHG inventory compilation? And to add up, what are the constraints for developing countries to anticipate on when planning the GHG inventory using bottom-up approaches?
Okay, thank you for summarizing the questions, Irina. So first question was about what are the differences between top-down and bottom-up approach. I think I lined out some of the difference, like the strengths and weaknesses in my presentation, but you probably mean the differences in numbers in Germany. It's actually different from year to year because also yeah, sometimes fuel can be sold in one year and used in another year, but I think I showed one graph and it's usually something below 10% for diesel and gasoline. And I think this is quite tolerable in terms of difference because it could be explained by people buying fuel abroad and using it in domestic purpose or the other way around. When we did an estimation for Vietnam recently, we found that there are really high uncertainties in the bottom-up calculation, and depending on that, also the differences from bottom-up to top-down was very high, like especially if we consider all the number of registered vehicles like ships or motorbikes, the bottom-up result could be almost double as high as the top-down. And there, of course, it is really hard to deal with this. It just gives an open question for the moment. And so it shows that there could be some room for improvement, both in the bottom-up, like finding the real number of in-use vehicles, correct VKT, but also on the other side, on top-down data. I think someone also posed the question if there could be a difference due to illegally imported fuel, like smuggling. And we already discussed this also for Vietnam, for example, that diesel fuel could be imported, especially from ships, from other countries, but used in Vietnam. I think there are often some different reasons which could serve for explanation. And if you find this type of uncertainties from two approaches, it should just be a motivation to further look at the uncertainties. I think there also should be some interest from the government, for example, if there is really a huge amount of smuggling to find out. So I think it is just very helpful to have both numbers to compare and discuss it. And I think this is also related to the second question, if developing countries should rather use top-down or bottom-up approaches. I think the best solution is always to use both if you have the data. And like I mentioned, for the total energy sales, there are, I think for many countries, there is data from the IEA, which could serve for a top-down approach. Sometimes it's not disintegrated into the transport modes, only in the total number of fuel sales. But still, this could help for comparing, like, what is the total fuel consumption of all my transport modes using diesel compared to the total fuel sales of diesel in a country. And then again, to have the possibility to validate the data and also discuss the uncertainties. So I would always suggest to use two approaches and compare the result. And Verena, can you read the last question again for me?
Of course, Christoph. It was, What are the constraints for developing countries to anticipate on when planning the GHG inventory using bottom-up approaches?
Yeah, I think the main like barriers are, of course, the data availability for developing countries. Due to my limited experiences for other countries, I think it is always something you have to figure out for your own country. How is the data availability? But I think, as I have shown, there's a lot of literature from international sources and also data collection from international sources. So I think it is always possible to applicate some bottom-up approach, maybe just a simplified bottom-up approach, or also using a bottom-up approach based on not so much country-specific, but of default data. And just as an experience from Germany, I think it is always like a developing process to have a bottom-up inventory. First, you do some calculations and get some numbers, discover some uncertainties and maybe uncertainties for the data, and then you can discuss it with stakeholders, with the governmental authorities, how this data can be improved. So it is already a step-by-step to improve the data availability and also the bottom-up approach. And I think there is a lot of motivation from different points to start with bottom-up approaches. I think for the greenhouse gas emissions, it's clearly due to the Paris Agreement, also for developing countries to better know the situation for greenhouse gas emissions of transport, but also there are other interests like the pollutant of air pollutant emissions, or for example, like I mentioned, the tax income from fuel sales. We also had some projects on this in Germany for some scenarios. So I think there are different fields which are interested in the results and in the data from a bottom-up approach. So it's always first to start.
Okay, thank you very much, Christoph. Yeah, I have one more question for Ms. Yen, which I found very interesting. How do you obtain the fuel consumption data? Isn't it easier to determine the mileage via the registration of the cars?
Thank you very much for very interesting questions. Yes, you're right. First of all, for the how to collect the fuel consumption data, we have two sources of fuel consumption data. First of all, that's from the energy balance. Ministries of industries and trade coordinate the energy balance studies. In the most recent available is in 2013, in which they identifies the fuel consumption by transport sector. So we got fuel consumptions from the MOIT sources. The others, but however, we need to break it down into the subsector by aviations, railways, DSN, FO, DOs for maritime and road. We for the aviation, we work with the Vietnam aviation authorities because recently Vietnam also need to report the emission to ICAO. Vietnam aviation authority started inventories of the consumption of the fuel consumptions a few years ago. So they got the form to deliver to all of to be reported by all of the airlines on the fuel consumption. So based on that, and also we got the invoice from purchasing the consumption for the plant. So altogether, we work out the fuel consumption for aviation, for example. Similarly, for the railway, we can identify, because in Vietnam we have only one railway operator, so it's really easy to manage to handle the fuel consumption for the railway. For the road, then so we based on the same of the DO and FOs, road and maritimes and inland waterways, and we based on the same, and also the energy balances for the DOs and FOs. So that's the consumption. Yes, you're right that it is easier and it's more precise, and that's either that we can have the mileage from the vehicle registration. And however, in Vietnam, we haven't recorded that data. And but for the inventory purposes, we are thinking of setting up the system. So from next inventories, for this inventory, it's now too late to start with that. But we still try to set up the procedure. So from next inventory, we will be having the mileage from the registration. I hope that answers your question.
So I will know, I want to say goodbye to our audiences. I'm pretty impressed that so many of you are still online, as we are already over our time planned. Thank you very much for your contributions to the discussion and the questions, and as I said before, we will still answer them. I actually wanted to do some commercials for our trainings and our knowledge products, but you will receive in our follow-up email, you will not only receive the link to the recording and the presentations of today, but also the links of our knowledge material that might be interesting to you. Like the paper that Marian already mentioned, the background paper on the MRV of measures. So we are very happy if you would also share the link then and the information to other interested people that you know. And if we do a webinar again, I hope you will participate again, and I hope you enjoyed it. So that's an overview on our trainings that we deliver, and we would be happy if you are interested if you contact us. Besides the training courses, we also offer study tours in Germany or provision of technical inputs from the expert network that the GIZ can provide. So these are the most important documents right now related to our to this topic that we were talking about today. The reference document on MRV in transport, and upcoming is also the transport volume of the UNFCCC compendium, but you can already find a preview version online. So other information, for example, on the BORs and national communications, you can find also on the Information Matters website. And now I just want to thank you for your patience, and you can contact us if you have any further questions. Thank you very much.